Hello everyone, welcome to Payment Tech Media. This video is part of video series about IP address. In this video you are going to learn everything you need to know about Internet Protocol version 4. Let's jump into my computer and take a look. So IP stands for Internet Protocol version 4. In this video we will talk about IP version 4. So in IP version 4 we have 32 bits. We have 4 octets, and in every octet we have 8 bits. And of course, every 8 bits equals 1 byte. Okay, now let's talk about the 32 bits in IP version 4. Internet Protocol version 4. We have 32 bits. Okay, so the 32 bits, first let's go ahead and start from left going to right. 1, 2, 3, 4, 5, 6, 7, 8. These are the placeholders for these bits. And every 8 bits it's separated by dots. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are the 32 bits, and in IP version 4, this is our first octet, second octet, the third octet, the fourth octet. In the previous videos, we talked about how we can convert binary into decimal value, and we talked about the binary number system, so I highly encourage you to watch here. We will talk about all the binaries and hexadecimal, and so that's the prerequisite. We need to be familiar with the binary, all that information. So the quick overview of what we talked about previously, these bits, they have decimal values. So for example here, the decimal value 1, 2, 4, 8, 16, 32, 64, 128. And again, 1, 2, 4, 8, 16, 32, 64, 128. 1, 2, 4, 8, 16, 32, 64, 128. 1, 2, 4, 8, 16, 32, 64, and 128. Now you might say where these numbers coming from. 2 to the power of bit position. So 2 to the power of bit position. This is bit position 0. This is bit position 1, bit position 2, bit position 3, and so on. And again, 0, 1, 2. Why 2? Because in binary number systems we have 0 and 1. 0, it's pretty much off. 1, it's on. Again, highly encourage you to watch here. We will talk about all the binary number systems and how we can convert binary to decimal. Okay, so 2 to the power of 0, it's 1. Any number to the power of 0, it's 1. 2 to the power of 1 is 2. And 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4, 16. 2 to the power of 5, 32. 2 to the power of 6, 64. 2 to the power of 7, 128. Again, why the base is 2? Because in binary number systems we have zeros and ones. So it's 2 numbers. That's why base is 2. And these are the bit position. The binary number bit positions. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. And so on. So base to the power of bit position gives us a decimal value. So these are the decimal value numbers. And these are the bit placeholders. And these are the bit positions. And this is the base. So just keep in mind these numbers 1, 2, 4, 8, 16, 32, 64, 128, 1, 2, 4, 8, and so on. These are the decimal values and where they're coming from. 2 to the power of bit position. Why 2? Because of the binary numbers, and these are the bit position numbers. So again, in IPv4 we have 32 bits, and here we can see all the 32 bits. And every 8 bits, it's separated by dots, so it's also known as octets. So this is the first octet, the second octet, the third octet, and the fourth octet. And this is the binary representation of IPv4. What we see in computer, for example, if we open up command prompt by clicking start and then typing cmd and then enter, it will open up command prompt. So let's type ipconfig, enter. So Internet Protocol configuration. So this is the command ipconfig, and this is our IP address 192.168.1.10, and the default subnet mask and the default gateway. And here when we talk about IPv4, these are the binary representation, and here is a decimal representation of IPv4. So here we can see the first octet, the second octet, the third, and the fourth octet. And each octet, the range goes from 0 to 255. Why? Because if I write 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, we already know the decimal values 1, 2, 4, 8, 16, 32, 64, 128. If all the bits turned off, that's 0. If all the bits turned on, that's 255. So this is an example of going from binary to decimal. And again, here you can see how we can go from binary to decimal. In the previous videos we talked about. Okay, so that's why when we talk about every octet, we have the range from 0 to 255. This is the decimal representation of IPv4. And here is the actual structure, the binary format, all the 32 bits and all the 4 octets. And we can see every octet, the 8 bits. So quick recap for this video, you should know how many bits we have in IPv4. There are 32 bits. How many octets? 4 octets. Every octet we have 8 bits. And you should know these decimal values for every octet, which goes from 1 to 128. You should know which one is the first octet. This is the first octet, second octet, the third octet, and the fourth octet. And when we convert the binary representation of IPv4 to decimal notation, every octet we have range from 0 to 255. Depending on the IP address. So this is known as IPv4 dotted decimal notation. And here, when we put all the binaries, the binary format of IPv4. So now, let's go ahead and talk about IPv4 classes. There are 5 different classes. Let's first talk about class A. The range for class A goes from 1, 2, 0, 1. So here we are talking about the ranges of these classes, class A, B, C, D, and E. For class A, in the first octet, it's pretty much all 0 except the last one, and it goes to the first 0 and all 1. For class B, the first octet goes from 1, 0, 0, 0, 0, 0. C is the first 2 on. D first 3 on, and E, first 4 turned on. So in class A, the first octet, which we talked about, this is the first octet. The first octet range goes from this binary to this binary, which when we convert the binary to decimal, gives us 1 to 127 in the first octet. And 127, I should talk about that, which is pretty much reserved for the loopback address. So for example, when you see IP address of 127.0.0.1, that's an example of loopback address. So this is the first octet, 127. It's reserved for the loopback address. Therefore, when we talk about classes, most likely you will see for class A, range goes from 1 to 126 in the first octet, because 127, it's reserved for the loopback address. And what is this loopback address? Mainly used for troubleshooting, testing purposes. So anytime when we ping the loopback address, for example, when we open command prompt by pressing start, typing cmd, enter, opens up command prompt, and when we type ping command for testing connection, so ping loopback address, ping 127.0.0.1, enter. It's basically pinging our computer, the TCP IP services, to see if it's up and running. So ping command by default sends 4 echo requests and 4 echo reply, uses the ICMP, Internet Control Messaging Protocol, for testing connections. And here we can see 4 echo request and 4 reply, 0% lost. So anytime when we are pinging 127.0.0.1, it didn't go through, it's most likely our computer. The problem is with our computer. It could be firewall, could be the network adapter, device driver, the TCP service is not running. So we have to start troubleshooting our computer. So this 127 address, it's known as loopback address for testing connection and troubleshooting. Okay, let's move on to class B. When we convert this binary to decimal, that's 1. So the decimal value is 128. If we quickly go over these decimal values for these binaries, so this one is 1, 2, 4, 8, 16, 32, 64, and 128. So this one, it's 128 turned on. So it is 128. And for class C, 128 turned on and 64 turned on. So 128 plus 64 is 192. And for class D, so 128 plus 64 plus 32, that's 224. And for class E, here we can see the first 4 bits turned on in the first octet. So 128 plus 64 plus 32 plus 16, which is 240. And here we can see for class A goes 1, 2, we talked about 127, it's reserved for the loopback, so we are using 126. And then the next one is 128, right? So 128 to what number? 1 less than the next one. So 128 to 191. And then for class C, the range is 192 to what number? 1 less than next class range. So 192 to 223. 223. And then for class D, 224 to what number? 239. 1 less than the next one. So 239. And for class E, 240 to what is the maximum number? 255. So just keep in mind, in IP version 4, we have 5 different classes. Class A, B, C, D, and E. Class D mainly used for multicast addressing, and the range starts with 224 to 239. And then class E starts with 240 to 255 in the first octet. And class E mainly used for research and scientific purposes. Class D used by routers, routing protocols, it's a multicast address. Class A, B, and C we will use to assign to the host interfaces, and mainly we will see subnet mask for class A, B, and C. And in the next video we will talk about the subnet mask more in detail. But before that, I'm gonna go ahead and write down multiple different IP addresses and ask you guys what class it is. So first, let's say 32.18.9.21. This one 125.64.18.5. This one 235.15.9.16. This one, let's say 85.315.19.21. Okay, let's take a look at the first IP address. This one, 32, this is the first octet. So looking at the first octet, 32 falls into what range? So 32 falls between 1 to 126. Therefore, this IP address is for class A IP address. Let's go ahead and move on to the next IP address. By the way, these are known as dotted decimal notation. Basically, these numbers are already converted from binary to decimal. So originally here we can see it's a binary number, but it's already converted to decimal, easier for humans to be able to read. But that's the actual 32 bits of IP address, and this is known as dotted decimal notation. Okay, looking at the first IP address, 125. In the first octet, 125 falls into which range? 125 still falls into the first range, between 1 to 126. So that's also class A IP address. Now let's go ahead. Next IP address. The first octet, 235. So 235 falls into class D range, because class D range goes from 224 to 239. Therefore, this IP address, 235, falls into class D. And next IP address. Well, if you guys said this is not a valid IP address, you are right, because we don't have here on the second octet 315. Remember, every octet, the range goes from 0 to 255. When we convert, if all the bits turned off, that's 0. If all the bits turned on, that's 255. So here, on the second octet, which this is the second octet, it says 315. 315, it's not a valid number in an IP address of the octet. So this was kind of tricky question. Be careful, this is not a valid IP address. If this was, let's say, correct number between 0 to 255, then looking at the first octet, 85 falls into still class A, so it would be class A IP address. But 315, that's not a valid number in an octet, so this is not correct IP address. In other words, we don't see IP address of, let's say, 192.65.18.9, or another word, 192.65.18.9. So we don't have dashes between the octet, we don't have colon between octet in IP version 4, we have dots, as we can see here. And of course, the numbers in every octet, it's pretty much from 0 to 255. Why? Because in 8 bits, the maximum number we can get is 255 if all the bits turned on. For example, if I quickly show you guys, on a third octet, let's turn on all the bits, and if we add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that's 255. And if all of them turned off, in a binary, again, in the previous videos we talked about, I highly encourage you, please make sure you watch here. So how we can convert binary to decimal. So if all the bits turned off, it pretty much, we don't need to add any of this value. Therefore, the decimal is 0. If all the bits turned on, we need to add the ones that already turned on. In this case, all the bits. So we have to add 128, 64, 32, all of them. When we add all together, that's 255. So that is why in every octet, we see the range from 0 to 255. And here, 315, that's not correct. So this is not a valid IP address. And these are not valid IP address. I'm going to write down another IP address and ask you guys what class it is. 165.19.32.64. If you said class B, that's correct. Because looking at the first octet, 165 falls into this range between 128 to 191. And that is for class B. So quick summary, in IP version 4, there are 5 different classes. We can see the first 3 classes used for the host and interfaces, and class D used by routing protocols and routers, that's a multicast address, and class E, it's for scientific and research purposes. And the ranges, always class A in the first octet, we can see the range goes from 1 to 126. Class B, in the first octet range, we can see 128 to 191. Class C, range 192 to 223. Class D, 224 to 239. And Class E, 240 to 255. Where this range is coming from, looking at the first octet, here, these are the bit values. And why is that? Because in class A, when a router receives a packet, looking at the IP addressing, IP address header, always, if it starts with 0, it knows that that's class A. Because if we look at class A range, it goes from 0 to 01. You see, all the range, always the first one, it's 0. So that's how routers quickly know, oh, that's class A. And for class B, 191, if we convert 191 decimal to binary, it will be 2, 1, 0, 1, 1, 1, 1, 1, 1. So let's count. It should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Very good. So always class B range goes from 1, 0, 0, 0, 0 to 1, 0, 1, 1, 1, 1. And of course, total of 8 numbers here. So always the first 2 bits in the first octet, it's 1, 0. And that's how routers know that this is class B. And looking for class C, always the first 3, very good, you guessed it right, 1, 1, 0. 1, 1, 0. So always the first 3, it's 1, 1, 0. How do we know? Because when we convert 223 decimal to binary, this is the binary for 223. And the next one, the range, you guessed it right, for class D, always it is 1, 1, 1, 0. And then the rest 0. 2, 1, 1, 1, 0. And the rest it's on. 1, 2, 3, 4. That's total of 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, when a router receives a packet, looking at the IP header, the first 4 bits, if the first 4 bits, it's 1, 1, 1, 0, it knows that this is class D, because in class D, the range always, the first 4 bits, 1, 1, 1, 0. And same applies for class E. Always the first 4 all turned on. When a router receives a packet looking at the IP header, always class E, the first 4 bits 1 1 1 1. So basically, in other words, 2. So we have the first 4 1 2 3 4, and the last 4 also turned on, and that's a total of 255. If all the 8 bits turned on, that's 255. But again, in class E, always the first 4 bits is turned on. So this was a quick overview of IPv4 classes. Again, we have 5 different classes. You should already know by looking at the IP address, how can we tell this IP address belongs to what class? You should already be familiar with the ranges. Class A ranges, for example, class B, class C, class D, class E. You should know and be familiar what is the purpose of class D address. Class D addresses mainly used for multicast purposes. Multicast communications are one-to-many defined groups. For example, one transmits to multiple different devices at the same time. So this is known as multicast communications, like let's say video conferencing and so on. And class E, it's used for scientific and research purposes. And always in the first octet, the range starts with 240. So if you see IP address, for example, let's say 242.18.9.24, you should say that this IP address, 242, that's class E address. That is mainly used for scientific and research purposes. So here we had some example of IP addresses. And looking at the first octet, we can tell if this is class A, B, C, D, or E. But just simply double checking and making sure if it falls into that range. Alright, now let's go ahead and talk about IPv4 subnet masks. So first we have default subnet mask, also known as Classful subnet mask, versus Classless subnet mask. First, we will talk about default subnet mask, the Classful subnet mask. Before we get into the subnet mask, what is the purpose of subnet mask? It basically determines what section of IPv4 belongs to the network and what section of the IP address belongs to the host. For example, when we have IP address of, let's say, 192.65.32.18, so looking at this IP address, first octet 192 falls into class C. So what is the default subnet mask for class C? It basically, the first 3 octets, it's for the network, and the last octet, it's for the host, which we will talk about it more. So that's the purpose of subnet mask. It gives us information what section belongs to the network, what section belongs to the host. Okay, first we will talk about Classful, or default subnet mask. For class A, B, and C, we have subnet mask. For class D and E, we don't have subnet mask address. Because class D, it's mainly for multicast purposes, one-to-many defined groups of communications. For class E, scientific and research purposes. So let's go ahead and talk about class A address. The default subnet mask for class A is 255.0.0.0. That's default subnet mask for class A. What does this mean? Means that in the first octet, class A, all the 8 bits are turned on. So for class A, if I write down all the bits here for the subnet mask, we have the first octet all turned on. And the rest, it's pretty much all turned off. These are the subnet mask address. And 1s represents the network bits, 0s represents the host bits. So if I ask you a question, for class A, how many octets do we have for network? Only 1, the first octet. So 1s represents the network bits and 0s represents the host bits. Therefore, we have 8 bits for network and 24 bits for host. You might see also this CIDR notation /8 CIDR. Classless interdomain routing, which we will talk about it more when we get to the VLSM or the classless subnet mask. So this /8 means that 8 bits fixed, 8 bits for turned on, 8 bits for the network. So the first 8 bits turned on, it gives us 255. If you remember previously we talked about anytime when we have 8 bits, all the 8 bits turned on, the value, decimal value is 255. So here this 8 bits on the second octet, it's all 0. That's why here on the second octet, when we convert the binary to decimal, we see it's 0. On the third octet, we have 8 bits, all 0. So here, converted to decimal, we have 0. And the last octet also the same, 0. So for class A, default subnet mask is 255.0.0.0, and the CIDR notation we can write /8. This /8, it's basically telling us the first 8 bits turned on. It's a network bits, and the rest turned off. So this is default subnet mask for class A. Now let's go ahead and talk about class B. Default subnet mask for class B is 255.255.0.0. What does it mean? It pretty much means the first and the second octet, it's all turned on. So we have 8 plus 8. Let me erase all this. 8 plus 8. So 8 ones plus 8 ones, and then 8 zeros, 8 zeros. So it gives us 255.255.0.0. The shorthanded version or the CIDR notation is 16, because if we count, this is the number of bits being turned on. So from left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is /16. 16 bits turned on gives us 255.255.0.0. What does it mean? For class B, we have 16 bits for the network, 16 bits for the host. So ones represents the network bits, zeros represents the host bits. Now let's move on and talk about class C. For class C, default subnet mask is 255.255.255.0, and the shorthanded version or the CIDR notation is /24. What does it mean? It means that for class C, we have the first octet, second octet, and the third octet all turned on. So these are the default subnet mask for IP version 4. For class A, 255.0.0.0, only 8 bits for the network. Here we can see the first octet. And for class B, we can see 255.255.0.0, 16 bits network. For class C, we have 255.255.255.0. So that's 24 bits for network, therefore 8 bits for the host. If we count 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros. So zeros is host bits, ones network bits. 24 plus 8, that's a total of 32. And that's what we see here in IP version 4, there are 32 bits. So these are the default subnet masks for class A, B, and C. So please keep in mind, we don't have subnet mask for class D, and we don't have subnet mask for class E. So here I'm going to write down multiple IP addresses. Let's say 194.18.32.16. Let me write down another IP address, 194.18.15.21. So if I ask you a question, these IP addresses, what class are they? Very good. Looking at the first octet, 194, we can tell what class this is. 194 falls into this range, between 192 to 223. So therefore, 194.18.32.16 is Class C address. Also this one, the 194, falls into this range, so that's also Class C IP address. Next question, are they on the same network? They are on the same class. Yes, 194, Class C. But are they on the same network? They are not, because looking at the default subnet mask for Class C subnet mask is 255.255.255.0, means that the first 3 octets must match. So here, 194, very good. Very good. First octet is matched. 18, very good. The second octet matched. 32, the third octet, it's not matched. So looking at the network portion of these IP addresses, we can tell that it's not matched. Because for Class C, the first 3 octets must match. Here, only 2 of them matched. 194 is Class C, yes, but they are not on the same network. Therefore, computers cannot ping this computer. It's not on the same network as this computer IP address. How do we know they're not on the same network? So looking at the IP address and based on the subnet mask, the default subnet mask, we can tell these 2 IP addresses, they are Class C, and the default subnet mask for Class C is 255.255.255.0. It means that the first, second, and the third octet must match. 194, the first matched. 18, the second octet matched. 32, the third octet not matched. So these 2 IP addresses, they are not on the same network. And these addresses here, known as a host address. So one computer, let's say .16, the other computer .21. Okay, I'm gonna go ahead and write down another IP address. Let's say 194.18.32.51. Again, we know this is Class C because 194 falls into Class C range. Here, as we can see, 194, it's between 192 to 223. And this is the range for Class C. And the default subnet mask for Class C, 255.255.255.0. So the first 3 octets belongs to the network, the last octet belongs to the host. And the first 3 octets must match. Let's see. So 194, very good, matched. 18, matched. 32, matched. Very good. So these 2 IP addresses, they are on the same network. They are on the same class and same network. But all these IP addresses, they are only on the same class. This IP address, it's not on the same network as these 2. So here we can see the main purpose of subnet mask, and we can tell that how important it is when we talk about subnet mask. It determines what section of the IP address belongs to the network and what section belongs to the host. And another thing that we need to keep in mind in the host portion, for example, if this IP address 194.18.32.51, if this was .16, and because here we have .16 already in use, and if these 2 IP addresses belong to the computers on the same network, same location, this is considered as duplicate IP address. That's not good, because in every local area network, in every LAN or segment, or let's say every room, all the computers or devices must have unique IP address. If we see two devices that using the same IP address, it causes IP duplicate, and none of the devices can communicate on the internet or on the network. So these two IP addresses, they are class C and on the same network because the network portion exactly matched. Therefore, the host portion also is unique, it's not duplicated. So it's a valid IP address and on the same network, and these two devices should be able to ping since they are on the same class and same network. Okay, let's have a couple more examples. Let's say this time we use, for example, 129. 129.81.16.15. Another IP address, let's say 129. This looks like 8L. Let me erase. This is 1. Okay, 129.81.16.19. This one, 129.81.121.15. So if I ask you a question, are these IP addresses on the same network? Can they ping each other directly without going through any router? And the correct answer is yes. Very good. Because first we want to find out what class are they, right? So looking at the first octet, 129, 129, 129. So this is class B because 129 falls into this range and it belongs to class B. And because they are class B, now we need to take a look at class B default subnet mask, which is 255.255.0.0. It means the first two octet belongs to the network and must match, must be exactly the same. And the last two octets are for the host, and it has to be unique. Okay, so here we can see the network portion and the host portion. The network portion in class B, 255.255.0.0, the first two octets must match. 129, 129, 129, very good. 81, 81, 81, very good. Therefore, all these three IP addresses are on the same network, and they are also on the same class, 129, 129, 129, and same network. And here we can see it's unique. 16.15, 16.19, 121.15, very good, they are unique. Okay, at this point, any IP address when I write down, you should be able to tell me what class this is and if they are on the same network, yes or no. So I'm going to write down, let's say, 132.18.9.54. 132.18.16.119. 154.16.19.25. Okay, let's take a look. Here we can see 132, 132. So these two 132 falls into this range. It's class B. 154 also falls into this range. Therefore, it's class B. So all these IP addresses class B IP address. And default subnet mask for class B 255.255.0.0 means the first two octet must match. So for class B, the first two octets belongs to the network, the last two belongs to the host. So 132, 132, 154. So 132, 132, 154. So 132 and 132, it's matched. 154, it's not matched. Now let's move on to the second octet, because again in class B, the first two octets must match, right? 255.255.0.0. So the first octet, so far the first two IP addresses matched. This one not matched. And the second octet, 18, 18, 16. So we know this 18 matched with this 18, and this 16 not matched. So we know these two IP addresses are on the same network. because the network portion, it's matched. All the IP addresses are on the same class B. So keep in mind here also, if we had 18, still it wouldn't be on the same network because the 154, it's not matched as 132. Or here, if we had 132 and here different number, still wouldn't be matched because both of the octet must be matched. So it has to be 132.18 to consider being on the same network. And here we can see the host portion are unique. So these two IP addresses, class B on the same network, unique IP addresses for the host, they can communicate. And here the last one, it's class B on different network because of this 154.16. These two devices can ping directly through the switch. This one, if any of these devices wants to talk to this one, has to go through the router if, again, default gateway address, IP addresses scheme set correctly, all that stuff. But it has to go through the router. It's not on the same network. Okay, so let's write down the network address, which also we do have the ANDing formula. It's basically if we convert the IP address and the subnet mask to the binary and then apply the ANDing formula, and the result, that's the network address. So to show you guys, if we write down this IP address, if we convert this IP address to binary, so 192, it's basically 128 plus 64, that's 192. The rest of the bits, it's off. So let's write down, we have 192, so that's 1, 2, and then we have 6 zeros because in every octet we have 8 bits, so that's 2 so far. 1, 2, 3, 4, 5, 6. And then 168 decimal, which we can use our calculator here, as we can see. So let's use calculator. We need to change the standard view to programmer view. And then making sure decimal is selected, which it is selected. So writing down 168. 168. And here we can see the binary is 10, 10, 1000. So let's write down for 168. 1, 0, 1, 0, 1000. And then 1, it's only this one turned on, right? Of course, on the third octet here, 1. So pretty much we have 7 zeros and only 1, 1. And then on the last octet, 58. So which of these decimal values do we have to add in order to get 58? Or we can just quickly use our calculator. So making sure decimal selected, 58, and in binary 0, 0. So let's write down 0, 0, 1, 1, and then 1, 0, 1, 0, 1, 0, 1, 0. Okay, next is writing down the actual subnet mask in binary format. So this 255, it pretty much means 8 ones. And it has to be aligned with this because when we apply the ANDing, not to make any mistake, this 255, 8 ones. And this 255, 8 ones. And then this 0 for the subnet mask, this is the last octet 0, so it's 8 zeros. Okay, now if we want to apply the ANDing, which is basically the only time the result is 1 if both of them turned on, the IP address and the subnet mask bit turned on. That's the only time the result is on. So this is on, so that's on, that's on. This is off, on, so that's off, on, off, off. Pretty much the rest of them it's off, because here we can see 1, 2, 3, 4, 5, 6, 7, and 8. Here 1, 1, that's on. Let me put dots. On. This is off, because again the only time it's on if both of them turned on. So this is off, on, that's off, on, that's on. Okay, so again both of them should be on. This is off, and this is both of them on, so that's on. And here 1, 2, 3, all of them it's pretty much off. So because again the only time the result is on, the actual IP address, the binary format, the bits, and the subnet mask, the binary format, the bits, both of them should be on. So here we can see this is off, and on. So when we apply the ANDing formula, 0, 1, that's 0, 0, 1, that's 0, 0, 1, that's 0. Both of them should be on in order for the result to be on. And alright, then here all of them it's pretty much off. Only the last one, both of them it's on. So we have 7 zeros, 1, 2, 3, 4, 5, 6, 7. The last one turned on, and here it seems that pretty much all of them it's turned off. 1, 2, 3, 4, 5, 6, 7, 8, because again every octet we have 8 bits, and here we can see 1, 2, 3, 4, 5, 6, 7, 8. So anytime when we have the IP address and the subnet mask, when we convert the IP address and the subnet mask to the binary format, and when we apply the ANDing formula, which again the actual bits for the IP address and the subnet mask, if it's on, the result is on. That's the only time the result will be on, if both of them it's on. Now this is our network address. Basically this IP address belongs to that network address. So when we convert this to decimal, which this one is 192, this one is 168, this one is 1, this one is 0. So this is the network address for this IP address. In other words, we talked about earlier that when we see IP address, first looking at the first octet, we can tell what class this is. In this case 192, that's class C, and the default subnet mask for class C is 255.255.255.0. So this 255.255.255, that's the network portion, network bits. 0 is the host bits, right? The host portion. So the network portion, 255.255.255, 192.168.1, 192.168.1. And 0, that's the host, right? So we put 0. So that is the network address. In other words, here, this was an example of using ANDing formula to get the network address, or we can just simply use the subnet mask and the cut line. So these 255, how many bits are they? 24 bits. If we count here, this is 8 bits plus 8 bits, that's 16, plus another 8 bits, that's 24, and then this is our cut line. To the left, these are the network bits, ones, network bits, zeros, host bits. And the last bit that is turned on, that's known as network increments or block ID, so which is by 1 on a third octet. Therefore, it's telling us next network, it's incrementing by 1 on a third octet. So for example, the next network would be 192.168.2.0. You see how this is 1 on a third octet, so we are here. This is on a third octet, first, second, third. This is on a third octet incrementing by 1. Why by 1? The last bit that is turned on, it's this one. So the decimal value for the last bit that is turned on, that's a network increment or the block ID. It's giving us information that what will be the next network. So the next network will be 2. And what will be the next one? 192.168.3.0 and so on. It's incrementing by 1. So, but this IP address that they gave us, 192.168.1.58, falls into the first network, because here we can see 192.168.1, 192.168.1.0. And okay, let's go ahead. We don't need this calculator. We can close. Let's close that. And if we want to go over the range, so this is our network address, and we have broadcast address. So the broadcast address is the last IP address. It's basically one before the next one. And in this case, 192.168.2.0. So this one, if you want to write down the broadcast address, before, let me quickly show you guys. You know how in decimal value we have 0, 1, 2, 3, so on, so on. When we get to 9, what happens? It basically turns to, after 9, it's 10, right? So this 9 turns to 0 and adds to the 10th place 1, correct? So we say 10. And then we have 11, 12, so on, so on, so on. When we get to 19, what happens when we get to 19? So basically this 9 turns to 0 and then adds to the 10th place 1, so it's a 2, 20, 20, correct? So kind of same applies here when we talk about this basically octets, all that. So for example, you see how here is 2.0. So what is the maximum, the last value in one octet? The range goes from 0 to 255. If we add one IP address, what happens? It turns to 0 and adds to the, basically to the left side octet, which is, here we can see 2. Therefore, for this network address 192.168.1.0, the broadcast address, the last IP address, basically, for that network is 192.168. Or it is 1.255. If we add one IP address to this one, what happens? It's not 256. So that turns to 0 and then adds to this place. So 256, that's not correct. It turns to 0 and adds to this 2.0. So here we can see 2.0. Okay, now we have our network address that representing this network. And here we have the broadcast address. That basically, if a router receives a packet that the destination is this address, the router knows that I have to forward the packet to all the IP addresses in that network. So that's broadcast address, broadcast communication. Broadcast communication means that one to any undefined numbers of devices, basically. All of them, depending, some of them are turned on, some are turned, doesn't matter. So it says to all, that's a broadcasting. Like let's say radio channels, the broadcast channel, right? And then we do have a multicast, which previously we talked about, which class, we talked about A, B, and C. That's mainly where we have this subnet mask. And then D, it's a multicast address, and E for scientific and research purposes. So this class D, as David, class D, it's a multicast address. Multicast address, it means that one to many groups, defined groups of basically devices. We can think of like XM radio. XM radio is like based on subscriptions. You have the subscription, you are part of the network, you can receive the multicast sessions. But the broadcast means anyone out there can receive this communication. So if a router receives a packet with the IP header destination address of 192.168.1.255, the router will forward basically that packet to any IP addresses in this range, which we will go over. So what is the first usable? By the way, this range in this parentheses, it's known as usable IP addresses. So this network address and the broadcast address we cannot use, we cannot assign them to the computers because it's used by applications, the routing protocols, routers, and so on. We cannot use and assign this IP address to an interface or to, let's say, a computer or printer, network print device. We cannot. It's mainly used by applications, routing protocols, and so on. So that's why we will do -2. We will talk about the formula and so on, but let's go ahead and talk about the available range for this network. So 192.168.1.1, that's the first available IP address. 192.168.1.1 to 192.168. goes from 1.1 less than the broadcast address 254. So 1.1 to 1.254, how many available IP addresses are they? 254. There's a formula if we want to find out the number of hosts equals 2 to the power of host bits minus 2. Why minus 2? Because of the network address and the broadcast address. We cannot use them, we cannot assign them to the devices on the network. It's mainly used by the programs and the applications, routing protocols and all that. So these are the usable IP addresses in this range. Let's see how many host bits do we have. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 2 to the power of 8 minus 2. So that's 256 minus 2, 254. So 254 available IP addresses we have for class C. Therefore, looking at this IP address 192.168.1.58, this is an example of an IP address in this network. This is the network address 192.168.1.0. That's a network address. So this 1.58 should be in this range, 1.1 to 1.254. What we did, they gave us this IP address. We looked at the first octet here, and we realized the 192, that's class C, and default subnet mask for class C, 255.255.255.0. These are the network bits, the host bits, and here we can see our network increment, the last bit that is turned on. This is the decimal value, that's the network increment, and here incrementing by 1 on the third octet because the last bit turned on is on the third octet. So in the default subnet mask for class C, we have 254 available IP addresses, a total of 256 IP address. Depending on the question scenario, if they ask how many usable or available IP addresses, it's 254 usable or 254 available IP addresses. If they say what's the total of IP address, we need to include the network and the broadcast. The total is pretty much 256. But the usable, the available that we can assign to the interfaces, to the basically host, computers, network printers, devices on the network, these are the available IP addresses. Now, if we take a look on the next network, 192.168.2.0, it's pretty much exactly the same. So what is the broadcast? The broadcast is one less than next one. So 3.0, it will be 2.255. So 192.168.2.255. If we add one IP address, it will be 2.256. We don't have 256, right? It will be 0 and add to the left octet, add 1. So it will be 3.0. And all right, so what's the range? So it will be 2.1 to 2.254. Let's write down 192.168. This is 2, right? 2.1. That's the first available IP address, and the range goes to 192.168.2.254. If we add one IP address, it will be 255, which is the broadcast address. So remember, these addresses here, these are pretty much all these addresses are the network address, and these addresses here, broadcast address. Broadcast address. So these addresses here, broadcast address, these addresses here, network address, and these addresses here all the available IP addresses, ranges basically. Okay, so in this network 2.0, 2.255, the broadcast, the network address, and the available IP addresses. Now, any IP address in this range, they can ping, they can communicate, talk together, they are on the same class, same network. For example, if I write down, let's say 192.168.1.1, so let's write down 192.168.1. Let's say 8. Let's write down another IP address, 192.168.1. Let's say 19. Another IP address, 192.168.1. Let's say 116. So all these IP addresses, based on its default subnet mask 255.255.255.0, they are on the same network, and they can ping simply just being connected to switch. They can talk together, they can communicate, and but if you have another IP address, let's say 192.168.2.18, so that's 2.1 to 2.254, that's on this network. So this is on different network. All of them same class, class C, but this one, it's not on the same network as these 3 IP addresses, because remember, class C is 255.255.255.0. So the first 3 is network, and the last one is the host, right? So the first 3 must match. 192, 168, 168.1, this is 2. It's not matched in the first 3. So we know this one is on a different network. Okay, let's say in this example they give us IP address of let's say 192.168.1.121, for example. And this is the IP address they gave us, and they gave us a Saturn notation of 24. So we know this Saturn notation 24, it basically means 24 bits turned on, or in other words, that's the actual default subnet mask for class C, because 24 is 255.255.255.0, 24 bits turned on. So let's count, going from left to right, 24 bits turned on. This is the subnet mask shorthanded version, right? So let's write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then the rest is 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here we can see our cut line. This is pretty much to the left, it's the network portion. To the right is the host portion. So all the ones means network bits, zeros means host bits. This is just another example of using default subnet mask for class C. And here we can see 192 network. So in other words, this /24 is 255.255.255.0. Pretty much this 24 bits we already counted, right, left to right, going all the ones, network bits. So if we convert this binary to decimal, so 1 means on, 0 means off, correct? So 1, the ones that it's already on, or 1, we just need to add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So that's 255. On this octet, same. If all the 8 bits turned on, so that's 255. This octet the same, 255. And the last octet, all the bits turned off, so that's 0. So this is our subnet mask. This is our IP address, which again, looking at the first octet for the IP address, 192. 192, it's in the range of class C. And default subnet mask for class C is 255.255.255.0, which again in previous videos we talked about a lot more in detail. This is just a shorthand version of the known as Saturn notation, classless interdomain routing /24. The /24 means 24 bits turned on. So the last bit that is turned on here is this one. This is the last bit turned on. Decimal value is 1. This is known as network increment or block ID. So if we want to write down this, this is the IP address, right? The network address we talked about using the ANDing formula, converting the IP address and the subnet mask and applying the ANDing formula. The result, that's a network address. But quickly also we can just write down the network address here because of the default subnet mask. Pretty much the octet of the 0, like this is 255.255.255, we just write down, and the octet 0 we just write down 0. So this 192, that's the 255, so we just write down 192. This is 168, this is 1, and the last one is 0, so we just write down 0. And this 121, that's the IP address in this network. So here is the network address, and we talked about, we have network address and the broadcast address. So this is the network address. And these are the available IP addresses here in between. So we also had the formula number of hosts. So again, number of hosts, it's pretty much 2 to the power of host bits minus 2. So in this case, how many host bits do we have? We have 8 host bits. So 2 to the power of 8, that's 256 minus 2, 254. 254. Why we do minus 2? To find the number of available IP addresses. Because of the network address and the broadcast address, we have to do the minus 2. So one IP address is for the network, one IP address for the broadcast. So 254 available IP addresses we should see here in this range. Alright, the first one, 192.168.1.1, 192.168.1.1, and it goes to the range of 192.168.1. What is the broadcast? Pretty much always the range is 1 less than the broadcast. And the easier to find out, I usually go by the next network. So the increment is 1. Right here, the last bit turned on, our block increment 1 on the 3rd octet. So let's write down the next network would be 192.168.2.0. So 1.0 incrementing by 1 on the 3rd octet, 2.0. What would the next one? 3.0. What would the next one? 4.0, and so on. So right now we are on this network, 1.0 network. So these are the available IP addresses. What would be the broadcast? The broadcast 1 less than next network, so 2.0. Well, here 1 less than 2.0, it is 192.168.1.255. Because we talked about earlier, in every octet, the range goes from 0 to 255. We don't have 256. So if we add one IP address to this one, would be 1.256, right? But we don't have 256. Therefore, it turns to 0 and adds 1 to basically the other octet to the left. And in this case, since we already have 1, so 1 plus 1 is 2, 2.0, which here we can see 2.0 for the next network. Okay, let's erase all this. And so this is our broadcast address. This is our network address. That's the next network address. These are the available IP addresses. So the range 192.168.1.1 because 1.0. So the first available 1.1, and it goes to 1 less than broadcast 1.254. So this IP address 192.168.1.121, it falls into this range 192.168.1.1 to 192.168.1.254. 121, it's in this range, one of the available IP addresses in this range. Therefore, this IP address belongs to this network. And actually earlier we saw, and again if we apply the ANDing formula, we should get to this network address. So all these IP addresses in this range, they can ping each other directly, just going through the switch, and because they are on the same network. This one, however, is a different network. If we have the range, the broadcast address, so any IP address here in this range, that's the different network. And this is the 192. So this is the 192.168.1.0 network, and these are the available. These are the available IP addresses in that range. And that's the broadcast address. So broadcast address here, the network address, and all the available IP addresses. In this video, let's talk about class B default subnet mask. Let's say they give us the IP address of 172.16.1.25. And they give us the CIDR notation of 16 or the subnet mask of 255.255.0.0. Okay, so looking at the IP address 172, this is the first octet. 172 belongs to class B. Class B default subnet mask 255.255.0.0, or the CIDR notation of /16. 16 bits, it's a network bits. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, or basically subnet mask. This is the decimal value. If we convert the decimal to the binary, 255 means 8 ones on the first octet. This 255, 8 ones on the second octet, 0 on the third octet, 0, pretty much we have 8 zeros. And then here on the fourth octet, 0, so we have again 8 zeros. Okay, so this is an example of default subnet mask using class B IP address. And so they gave us the IP address, default subnet mask. Now after going through basically all the bits, here we can see where is the cut line, and our cut line is here. These are the network bits and these are the host bits. So we have 16 network bits and 16 host bits. Now looking at the last bit that is turned on, here the decimal value for the last bit, it's 1. So this is our network increment by 1 on second octet. So if you want to write down the network address, 172.16.0.0. So basically 255.255.0.0, that's the network address would be 172.16.0.0. So let's write down our network address. So we have 172.16.0.0. This is our network address. And let's see, if I want to write the broadcast address, always it's better to have the next network. Then one less IP address would be the broadcast address. Okay, so what is the next network? How can we find out? You see here earlier we talked about the last bit turned on. This is our network increment on a second, so it's by 1. Therefore, it is 172.17.0.0. Why? Because on the second octet incrementing by 1. Second octet, so if we had .16, now it's .17, and so on. What would be the next network? The next network would be 172.18.0.0, and so on. So, well, the broadcast for the first network, 172.16.0.0, the broadcast is always 1 less than next network. So next network 172.17.0.0. So would be 172.16.255.255. Okay, so let me explain what happened here. So this IP address, which is the broadcast address, if we add one IP address to this, so it would be 172.16.255.256, which again we don't have 256 in octet, correct? So this is not correct, and therefore what happens, it basically turns to 0 and adds to this octet to the left. Then it would be this one would be basically, it would be 172.16.256.0, which again we don't have 256. So here also would be 0. So it would be 0, and it will add the 2 basically to the left here by 1. So that's why we see 172.17.0.0, which is this one here. So when we have 172.16.255.255, when we add one IP address, it will be this 172.17.0.0. Therefore, when we want to find the broadcast address, it's always the easiest way to simply find the next network. How can we find the next network? By the increment. How did I get the increment? By using the subnet mask. So the subnet mask, we did find the cut line 255.255 means 8 ones here, 8 ones here, and then 8 zeros, 8 zeros. So between ones and zeros, draw a cut line, and these are the network bits, these are the host bits. So the last bit turned on, that's our increment, network increment, and we have to pay attention what octet is our increment. This one, it's on the second octet. So this is the first octet, that's the second octet, the third octet, the fourth octet. So this is on the second octet. So we are incrementing by 1 on a second. So here the second octet, if this is first, second, third, and fourth, so the second octet, 16, incrementing by 1, 17. So we know that's our next network, correct? So now we can come back here and say, how can we find the broadcast address? Broadcast address is always one less IP address than the next network. If the next network is 172.17.0.0, the broadcast would be 172.16.255.255. And now let's go over the range. Okay, so 172.16.0.0. The first usable IP address would be 172.16.0.1. That's the first usable IP address. And it goes to 172.16.255.254. That's the range. So if we add one IP address, will be 172.16.255.255 here. So always the last available IP address is 1 less than the broadcast. And the first available IP address is just 1 after the network, adding 1 IP address to the network address. So 172.16.0.0, adding 1 IP address would be 172.16.0.1. It goes to 172.16.255.254. Now again, the same formula we talked about earlier to find out the number of hosts or available IP addresses. So we have 2 to the power of host bits minus 2. In this case, we have 2 to the power of how many host bits do we have? Zeros represents the host bits. 16, correct? Minus 2. Why minus 2? Because of the network address and the broadcast address. We cannot assign the network address and the broadcast address to the computers on the network. So these are the usable IP addresses here in this range. These are the available IP addresses. So to find the host number, we have to do the minus 2. 2 to the power of host bits minus 2. 2 to the power of 16, 16 host bits. How do we know 16 host bits? Again, because of the subnet mask, 255.255.0.0. Why the subnet mask is 255.255.0.0? Because our IP address is class C. How do we know it's class C? Looking at the first octet, 172, that's class C. So earlier in previous videos, we talked about how we can find out looking at the IP address if that's class A, B, or C, and please watch those videos if you haven't watched those. So yeah, this is class B because 172 falls into class B IP address, and class B IP address default subnet mask is 255.255.0.0, and means that we have 16 ones and 16 zeros. This is our cut line. So 2 to the power of 16, these are the host bits. Zeros, host bits, ones, network bits. Okay, so 2 to the power of 16 minus 2 equals, first let's take a look, 2 to the power of 16, it is 65,536 minus 2, it is 65,534. So that's how many available IP addresses in class B default subnet mask. So this is class B. That's the available IP addresses. This range should be 65,534 available IP addresses in class B. Now this IP address that they gave us, 172.16.1.25, it basically falls into this range, the 172.16.0.1 to 172.16.255.255. It's in here. So the network address would be 172.16.0.0 for this IP address. Now let's go over default class A subnet mask. So let's say they give us IP address of 10.10.0.18, for example. And we already know this is class A, 10, the first octet, falls into class A range. And the class A default subnet mask is 255.0.0.0. Or in other words, we have the Saddle notation of 8. This means 8 bits turned on. In the first octet here, we have 255, right? So let's go over the number of network bits. We have 1, 2, 3, 4, 5, 6, 7, 8, right? 255, 8 bits, and then the rest of the octet all 0. So it's off. Let's write down all the host bits. Alright, so now where is our cut line, where is our network increment? So this is just again one class A IP address with the class A default subnet mask, and we already know for class A default subnet mask is the first octet is network, the rest of them is host. So we just need to write down the cut line between the network. 1 represents network, 0 represents host. So let's just write down, this is basically to the left network and to the right our host bits. So we have 8 bits for the network and 24 bits for the host. So we already talked about the number of the formula that we already talked about earlier. So the number of hosts, it's pretty much equals 2 to the power of host bits minus 2, which here we have 2, how many host bits we have? 24, right? 24 minus 2, and why minus 2? Because of the network address and the broadcast address, which you will see we talked about earlier, and you will see later on. So 2 to the power of 24 minus 2 is 16,777,214 IP addresses. So therefore, in every class A network, we can have up to 16,777,214 available IP addresses, because we talked about to find out the number of hosts. For if this is class A, B, or C, it's just simply 2 to the power of host bits minus 2. So for class A, we have 24 zeros, so 24 host bits. And you guys saw earlier in the previous videos that in class B, we had 16 zeros, right? 16 host bits. And in class C, only 8 zeros, 8 host bits. So we had different values. And all right, so well, here we can just write down our basically network address. So the network address would be here 255. This is 10, so just simply writing 10.0.0.0, and then the increment here we can see on the last bit that is turned on. This is the last bit turned on. And this is our network increment. So on the first octet, so if this is 10, next network would be 11.0.0.0. Next network would be 12.0.0.0. Remember, this is just a default subnet mask for our class A, which is 255.0.0.0. And when we have the cut line, the last bit turned on, the decimal value is the network increment to find out the next network. Okay, so these are the network addresses. Here we can see in this column, And then to find out the broadcast, always it's better to find the next network, right? And then one less would be the broadcast address. So the broadcast address for this network would be 10.255.255.255. If we just add one IP address to this, it will be 10.255.255.256. We don't have 256, so it will be 0, and add to this one 10.255.256, 0, and again we don't have 256 here, so it will be 0, adding to this one 10.256.0.0, and here we don't have 256, it will be 0, and adding to this one, so it will be 11.0.0.0, and here we can see 11.0.0.0. Alright, let's write down the available IP addresses. So the first available IP address is 10.0.0.1, and it goes to the range of this 10.255.255.254. Always one less than the broadcast. Okay, so to find the broadcast address is one less than the next network. How can we find the next network? Using the increment. How did we get the increment? Using the subnet mask. How did we get the subnet mask? Using the IP address, what class it is. This IP address, looking at the first octet, this is 10, is class A. So we know the default subnet mask is 255.0.0.0 for class A. Therefore, this is 255, 8 bits turned on, right? It gives us 255. And then the rest of the bits turned off, which this is our cut line. The last bit turned on, decimal value, increment on the first octet. So incrementing by 1 on the first octet, we can find the next network. So 10, next network would be 11, next network 12, and so on. So the IP address they gave us is a 10 network. Therefore, looking at the 10 network, finding the next network, broadcast one less than next network. So 11.0.0.0, one less would be this, 10.255.255. And then when we have the network address and the broadcast address, then we can have the range. And the range in between, the first available IP address for this network is 10.0.0.1, and it goes to 10.255.255.254, one less than the broadcast. And this IP address 10.10.0.18 falls into this range. So this was an example of using class A IP address with class A default subnet mask, which in this network we have a total of 16,777,214 available IP addresses in this one network. Okay, so for class A, we have 8 bits for the network, which gives us the default subnet mask of 255.0.0.0. And it gives us, for every network, we can have up to 16,777,214 available IP addresses. We talked about the number of hosts is 2 to the power of host bits minus 2. So for class A, we have 8 network bits. Therefore, it gives us 24 host bits. So in class B, we have 16 network bits. And the default subnet mask is 255.255.0.0. And the available IP address is 65,534, which we have 16 host bits as well. So 2 to the power of 16 minus 2, 65,534 for every network. And then class C, we have 24 network bits, which the default subnet mask is 255.255.255.0, and which is 254 available IP addresses, and it gives us 8 host bits, because 24 plus 8 32. 16 plus 16, 32. 8 plus 24, 32. And again, IP version 4, we have 32 bits. And if we quickly go over the ranges, for class A, we talked about 1 to 127. Which again, 127, it's reserved for loopback. It's better to write down 126. For class B, range goes from 128 to 191, because class C is 192 in the first octet, and it goes to 223 because class D, which we talked about mainly for multicast purposes, range goes from 224 to 239. And then class E, scientific research purposes, 240 to 255, the range. So when we see IP address, let's say 183.19.21.56. So this IP address, what class this is, 183 falls into what range? Class B, between 128 to 191. So 183 is class B, and class B default subnet mask is 255.255.0.0. And the network address for this IP address would be 183.19.0.0 according to the default subnet mask. And in every network, we can have up to 65,534 available IP addresses in this network based on this subnet mask. So we have 16 bits for network, 16 bits for host. An example of class B, because of 183, looking at the first octet, we can tell if this is class A, B, C, D, or E. Just remember, class A, B, and C, we have the subnet mask. Class D for multicast purposes, and then class E for scientific and research purposes. So in this video, we will talk about the differences between default subnet mask and classless subnet mask. Okay, so these are known as default subnet mask. Now what happens if we don't want to use default subnet mask? So that's known as using subnetting. So subnetting, it's pretty much very useful in order to be able for better manage and organize our network, not to waste too many IP addresses, and for security reasons. We will see and taking the advantage of subnetting. So, and anytime when we talk about subnetting, we have to use classless subnet mask. For example, if we use default subnet mask, and let's say if this is for class C network, we already know default subnet mask for class C, it gives us 254 available IP addresses. Let's say if we don't want to use 254, if we have a network, let's say our accounting department, it's only 16, or human resource only, let's say 8 employees, and in the sales we have only, let's say 24 employees or computers, let's say we need IP addresses, but we don't want to use 254. And so it is better to use classless subnet mask, not default subnet mask. And how can we do that? It's basically by using the number of bits. For example, instead of using this default network bits, just simply borrowing from the host bits. And for example, if we, let's say, which that's also another formula depending on number of hosts or number of subnets, and we will see different values. But if we quickly go over, if we already know for class A is 8, and this 8 means we have 1, 2, 3, 4, 5, 6, 7, 8 bits already turned on, going from left to right, right? These are the network bits. And so if we add the decimal values, so 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that's 256. 5. Now let's say if it is, let's say 9. So we are basically borrowing 1 bit from the host, right? So now it is 1, 2, 3, 4, 5, 6, 7, 8, 9. What is our new subnet mask? So the new subnet mask would be, it looks like 19, but that's /9, basically known as the CIDR notation, classless interdomain routing, and the CIDR. So this /9, 9 bits, network bits, 9 bits turned on. This is the 9 bits. What is our subnet mask? So subnet mask is basically just like converting this binary to decimal. So here it's only one of the bits turned on, right? So the rest of them it's off. Therefore, a subnet mask would be 255 dot this one, only this one turned on, 128, right? So 128 dot here, all the bits turned off, all the bits turned off. So 0, 0. Now let's say if this is /10. So 10 bits, right? So let's count left to right, 8 plus 2, 10. What would be the subnet mask? So the subnet mask is basically 128 plus 64 on a second octet, right? The first octet we already know, 255, all the bits turned on. So 255 dot here, 2 bits, 128 plus 64, that's 192 dot 0 dot 0. And so on, /11. So we add one more. So here, these are just one examples. If we want to use basically the CIDR classless interdomain routing instead of using the default subnet mask and just borrowing one more bits. So here we have 8, 9, 10, 11, right? So 128 plus 64 plus 32. So 128 plus 64, that's 192 plus 32, 224 on the second octet. So here 8 bits, it's on the first octet, so that's 255. When we add all the ones that are already turned on, that's 255. And let's go ahead and add. Here we have 128 turned on, 64 and 32, that's 224, 0, 0. And let's go over 12. So 12, let's add one more. Here we see 8, 9, 10, 11, 12. And it gives us the first octet, of course, 255. And here should be 240 because 128 plus 64 plus 32 plus 16, that's 240. By the way, it's a table. If you remember and memorize this table quickly, you can tell what is the actual decimal value of these binary numbers, because remember, always goes from left to right and it's just borrowing by 1 bits, right? So let's go over this table. Anytime when we are borrowing 1 bit, so speaking about borrowing, we are getting this bit from the host section. So if it was class A, by default we have 8 bits, that's a network. These are 0, that's the host bits. So we are borrowing from the host bits right now. Like if we add one more, it's just borrowing one more bit from the host, from all these zeros. So usually you will see reading basically textbooks, authors, they refer to as borrowing bits, borrowing from these host bits and turning it to the network bits, which in other words, basically it will be, these are our network bits, these are the borrowed bits, our subnet bits, and the rest of the zeros is pretty much host bits. Okay, so let's go over this table. Anytime when we are borrowing 1 bit, so when we're borrowing 1 bit, always is 128. Anytime when we're borrowing 2 bits, it's 192. 3 bits, it's 224. When we borrow 4 bits, it's 240. When we borrow 5 bits, it's 248. When we borrow 6 bits, 252. When we borrow 7 bits, 254. When we borrow 8 bits, it's 255. So always keep in mind, this is the table that you need to memorize, remember, and so because always is the same. For example, let's go over, you know what, we take A, B, and C, and all of them, let's add by, let's say, you know what, let's say 5, okay, so if we add 5 bits, so if this is 8 plus 5, that should be 13, right? So / if this is class A, / 13. B, 16 plus 5, so that's 21, right? So if this is B, 21. And then C, 24 plus 5, so 29. So C, 29. Okay, let's see if this one, 13, what would be 13? So we have the first 8, right? That's 255. And then 13, we basically added 5 more bits, correct? So 5 plus 8, that's 13. And anytime when we borrow 5 bits, 248. So it should be 248.0.0. Why? Because let's count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is our cut line. So if we convert, and these are 0, if we convert all the ones to basically these binaries to decimal, so the ones turned on, we just need to add 128 plus 64 plus 32 because all turned on, right? Plus 16 plus 8, 4, 2, 1, that's 255. And here we have 128 plus 64 plus 32 plus 16 plus 8, so that's 248 on the second octet. You see, 5-bit borrowed because, again, A, default subnet mask is 8. Now it says 13. We know this is a classless subnet mask. It's not a default subnet mask. They borrowed 5 bits, correct? So anytime borrowed 5 bits is 248. Okay, here, class B 21. We know this is not a default subnet mask. They borrowed 5 bits, and this is basically for class B. By default already we have 255.255 dot here on the third octet, because when we add 20, it is 21, correct? So 8 plus 8, what is it? That's 16. 17, 18, 19, 20, 21. That's 5 bits, 5-bit borrowed. So we know we are on a third octet. So when we borrow 5 bits, again, same thing, 248.0. Now let's take a look at class C. Class C IP address, they gave us a Saturn notation 29, and we already know this 29, they borrowed 5 bits from the host bits because by default class C is 24. So 24 plus 5, that's 29. Therefore, the default subnet mask is 255.255.255. On the last octet, the host bits, they borrowed 5, correct? 29. Let's count. 8 plus 8, that's 16. Plus 8, that's 24. 25, 26, 27, 28, 29. They borrowed 5 bits from the host, okay? So here should be 248. That's it. You see all of them, we see 248. But of course on different octets. So that's why I talked about this one. It is very important to understand if anytime when we borrow specific amount of bits from the host, what would be the result? Always is the same. Anytime when we borrow 1, it's 128. Anytime when we borrow 2 is 192. And of course, it the only difference is just on what octet, which again, when we count, like let's say this one, 21. Let's count 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's erase this. Okay, 13, 14, 15, 16, 17, 18, 19, 20. It was 21, right? 20 and 21. So we said 21. Okay, so 8 plus 8, 16, 17, 18, 19, 20, 21. Okay, this is our cut line. And we already know 8 bits turned on, that's 255. Okay, so that's 255. And here 8 bits all turned on, so that's again 255 on a second octet, 255 on a second octet. And then here we have only 5 bits basically turned on, borrowed. In other words, the rest of them it's off. That's the host bits. Zeros, host bits, ones, network bits. Okay, so here in this case, when we talk about 21, they borrowed 5 bits, so we can see on the third octet, because 8 plus 8, 16, 17, 18, 19, 20, 21. So that's on the third octet. We just write 248 on the third octet because this is on the third octet. When we convert this binary 1111100 to a decimal, it gives us 248. So again, please make sure you watch my other videos. I talked about how we can convert to binary, to decimal, and all that details I talked previously. If you haven't watched those videos, make sure you watch. And it clearly goes over how we can convert binary to decimal, decimal to binary, all that. Okay, so yeah, this is comes very handy and useful. One example, let me go ahead and give you guys one side of notation quickly. Let's say 19. Okay, so we know by default for class B 16, right? So we borrowed how many? 3. So anytime when we borrow 3, what is it? 224. On what octet? On a third octet, because 16, that's 255, 255 already, 8 plus 8, correct? So 255 dot 255 dot, so notice 19, 3 bits borrowed on a third octet, so 224, it should be 224, and the last octet is 0. That's it. Quickly, you just converted this side notation of 19 to the full version of the subnet mask. And we know this is not a default subnet mask because 255.224.0, that's not a default subnet mask. The default subnet masks we can see here for class A, 255.0.0.0, for B, 255.255.0.0, for class C, 255.255.255.0, and a shorthand version of how many bits it's basically turned on, how many network bits. For class A, 8 bits network bits we have. For class B, 16 bits network bits. For class C, 24 network bits. Which again, in other words, when we have these bits, binary bits converted, because it's already turned on, right? Converted to decimal, it gives us these decimal values. For 16 is 255.255.0.0. For 8, 255.0.0.0. And for 24, 255.255.250. Okay. So 19, the /19, again, we already know by default for class B 16, therefore 16 plus what? Gives us 19, 16, 17, 18, 19, 3. So looking at this table, 224 here on a third octet, 255, that's the 8 bits, 255, that's another 8 bits, so 8 plus 8, 16, so it gives us 255, and we need 3 more. So we are on a third octet, 224. And then the last octet, it's all 0. Now let's see. So here, if I erase all this, and if I go back, we have 8 plus 8, 16, 17, 18, 19. And let's draw, this is our cut line. So 0, 0, 0, 0, 0, the rest of them 0. Okay. So we have 8 plus 8, 16, 17, 18, 19. So we have only 3 bits turned on. If we convert this binary, these binary numbers 1110000 to decimal on the third octet, so it basically means that the ones already turned on, we just need to add 128 plus 64, that's 192, plus 32, 224, and that's it. So it's only these 3 numbers turned on, so we just need to add these 3 numbers. So we have 224 here on the third octet for the /19. And same applies for any other side notation. if this is a /, you know what, I said 3, correct? So 8 plus 3, that's 9, 10, 11, which it gives us 255 here on this octet would be 224.00 if this is 11. And actually here we can see we already have, for example, /11, 255, 224.00, where the 224, again, it's coming from when we talk about 11, we just need to count. If I erase again, let's count. If I go back, we have left to right, let's count 11, right? Because these number of network bits turned on. So left to right, 1s represent network bits, 0s represent host bits. So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So this is our cut line. All the rest, it's 0. Alright, so remember this is all our subnet mask, right? Subnet mask bits. And so here we have 8 plus 3, that's 11. So 8 bits turned on. If we convert this binary to decimal, we just need to add all these decimal values because all of them turned on, and it gives us 255. And here only these 3 we just need to add. So 128 plus 64 plus 32, because only these 3 turned on. 0, it's off. We don't need to add these numbers. So it gives us 224 on a second octet, and the rest of them 0 here, as we can see for the /11. So this is kind of like quick comparison when we talk about the default subnet mask. And in the default subnet mask, again, we already talked about earlier previous videos how many available IP addresses we can have in each class by using default subnet mask. But let's say sometimes we don't want to use all that IP addresses. We want to use let's say less. We don't have that many employees or that many devices on the network, and or to better manage our network, better organize, and or maybe for security reasons. So that's where the classless interdomain routing comes into play. That's where the subnetting, known as subnetting, breaking a large network into the smaller networks. So that's the subnetting comes into play. And how can we subnet network? By just simply using classless subnet mask, which simply by borrowing bits from the host bits when we talk about the subnet mask, not to use the default subnet mask. I hope this video was helpful. In the next videos, we will talk about subnetting, supernetting, so stay tuned. Thanks again for watching and have a good day.